This is the final part of derivative calculus, which is what all of this is on. We're talking about derivatives and stuff. I'm going to do a little review and hint towards the next one, okay? Next part of this. I'm going to introduce you to compound functions, which is f of g of x. Okay? What does this mean? Well, say f of x is x squared, and g of x is x. Or, more interestingly, e to the x. Now, f of g of x is like replacing all of the x's in this equation with g of x. So this is going to be g of x squared. But what's g of x? Well, it's e to the x. Square it, multiply that 2 down, it's e to the 2x. Okay? So now, what's the derivative of some f of g of x? Well, turns out it's the derivative of f in respect to g times the derivative of g in respect to x. What does this mean? Meaning, if I have, say this, e to the 2x, which is where f of x is x squared, and e to the x is going to be g of x. So it's going to be the derivative. Well, here's a better way to think of it. It's the derivative of e to the 2x, right? So we could view this as e to the x, which is f of x, and 2x as g of x, meaning f of g of x is going to be e to the 2x, right? So, in this case, we're going to do the derivative in respect to 2x of e to the 2x, right? Times the derivative in respect to x of 2x. Which is then going to be, well, you can kind of see what's going on here. 2x is kind of like y, right? If I make substitution y equals 2x, y, e to the y, right? So that's going to be, well, e to the y still, times 2. It's going to be 2e to the 2x. Okay? Now, this doesn't have to make sense. I never introduced this to Tyler in class, but in the club. This is not a class. I'm not a teacher at all. I'm not very good at this. But I still do it. So, now, this doesn't really make much... This probably doesn't make much sense right now, so I'm going to expand on it. Of composing functions. This is what's going on. If f of x is e to the x, yeah, and g of x is going to be e to the x. F of g of x, replace all of the x's in this with g of x, so this is going to be e to the g of x, which gives you e to the x, okay? Now taking the derivative of this, right, of e to the x, you can see what our two functions are. So it's going to be the derivative in respect to g of e to the g, right? That's really what we're doing, because g of x is e to the x, and that's what's up here, times the derivative in respect to x of e to the x. This gives us e to the g times e to the x, which gives us e to the x times e to the x. This is going to be, we're not going to do anything on this. It was just something that I thought I'd bring up before we got into the bigger picture of all this. So now, I'm going to give you some more examples, just so that this kind of solidifies. If I'm doing, say, x to the x, well, I'm going to do a different thing. X to the x is y, dy dx. What's that going to be equal to? Well, we can do something called implicit differentiation. It's kind of weird. So, we say y is x to the x, and there's a property that the natural log of n to the x is x natural log of n. Okay? Now, really quickly, I'm going to tell you that the derivative of the natural log of x is 1 over x. You're going to have to trust me on this. Okay? You're going to have to trust me on that. But it is true. So, take the natural log of both sides. Natural log of y equals natural log of x to the x, which is going to be x times natural log of x, right? Now let's take the derivative of both sides, right? Now what should we do? Well, this is just the chain rule, because this is the natural log. This is some f of y of x, right? And f just happens to be the natural log of x, right? This is f of y of x. Now on this hand, you do the product rule. Left d right plus right d left. 1 plus natural log of x. So, we know that this is going to be the derivative of 1 in respect to y times the derivative of y in respect to x, right? But now, what's this going to be? Well, natural log of y, derivative of that in respect to y, is going to be 1 over y, right? Times dy dx, right? Because derivative of natural log of x is 1 over x. So the derivative of natural log of y in respect to y is going to be 1 on y. Then we get 1 plus natural log of x. Multiply by y on both sides. Y times 1 plus natural log of x. But you know what y is. It's x to the x. So the derivative of y in respect to x is going to be x to the x times 1 plus natural log of x. Okay? This video is highly optional, but now I'm going to do a bunch of review questions over the entire calculus we've been doing. So, what is the derivative of x squared times e to the x? What is the derivative of 3 to the x times x, the quantity of x cubed plus x squared plus x plus 1? Quite a long one. 3. What is the derivative of e to the 3x squared. Number 4, what is the derivative of 1 over x plus 1? Or rather, 1 over x squared plus x. There we go. Derivative of 1 over x squared plus x. And this is the end of Calculus Part 1, Part 5.